This is the second part of looking at coastal processes, often referred to as geomorphological processes. This is the beginning where I look at subaerial processes. Two key parts of this will be weathering and mass movement. In this session today, I'll focus on weathering. And just to remind ourselves, alluded to this in the previous part one about subaerial processes. And remember, um, you're often asked to discuss both marine processes and subaerial processes, which are separate. There's a little bit of overlap with some of the conditions, factors at work, but often you'll use this as a factor. So at the risk of repeating some elements of again, I do feel we need to reinforce what this means. So subaerial, if I just highlight the laser pen. So under the air, we're talking it's predominantly land-based. So I think in your eyes, definitely keep it as separate from the sea, marine, here with the erosion, transportation, deposition. And I would say there are three key areas to think about this. You definitely need to make sure that you see weathering as a subaerial process, mass movement as a subaerial process, but also realize things like surface runoff, water going over the ground, infiltration where water goes in through the soil, especially if it's permeable into the rock, and it can change the nature, the weight of the soil and the rock, and therefore contribute to mass movement. So it's important to get all those elements into there because I know, for example, some of the questions they will ask you to explain the role of subaerial processes or assess the extent to which subaerial processes play a part. And I know from experience, quite a few students struggle with that concept. I don't think it's difficult. I just think the word subaerial is just not something you use very often. So it's like another language and you have to practice to kind of own it. And again, may have alluded to this, I can't remember the previous lesson now. Weathering is different to erosion. You'll definitely see that on the next slide. And again, I'm not apologizing for repeating this. This is the breakdown of rock in situ. That means on the spot. To a large extent, we're talking about where the rock disintegrates, breaks down, breaks apart, largely in one area. It doesn't, and it can result then in mass movement. So it's the weakening of the cliff face, for instance. And there are several types that we'll be looking at in today's lesson. So this will be the key focus of the session today. Mass movement, a downward movement of material under the influence of gravity, your slumps, your slides, your rock falls, etc. That will be the next session. So again, want to make the clear distinction. And then without repeating these ones here, again, the classic, these two areas, you ask students to define these two, and they often get these muddled with their subdivisions. So with weathering, we're talking about breakdown of the rock in situ on the spot, whereas here we've got water moving. That's a good way to think about it. Physically moving, hitting the rock and breaking the rock. This also happens by things like glaciation, ice, water, wind. And the key focus here that we're talking about is by water. We dealt with that in the previous lesson, and then there we've got that, the mass movement again. But it's worth practicing the distinction and making sure you're clear about that. As I said in the previous session, they have done things like weathering versus erosion, which factor is more dominant in the development of coastal landscapes. It's important to get that idea. So I'll start with this element here, go through the types of weathering, and then we'll talk about the importance of weathering on the coastline. This won't take too long. So there are three broad categories of weathering. Physical weathering, which you can see here, a bit of freeze thaw taking place, chemical weathering, and biological weathering. So starting with freeze thaw, I've put quite a few diagrams onto this slide. These kind of relate across. There are more than these. There's four here. That's just the way I've pasted this onto the PowerPoint. There are more things like wetting and drying, for instance, you could include, but I think there's enough range here to get some idea. And remember, this this look at weathering is about the role it plays in coastal development. So we don't need to get too detailed on the full range and the different environments. So we're looking at relative to what it can do at the coastline across the world, but also more importantly on the UK coastline. Freeze thaw, many of you know this quite well. This happens, you get it in temperate climates like the UK. You just need periods of time where it's cold so it can freeze. That might be overnight, it might be over the winter, but you also need it for it to warm up. So what we've got here, water enters cracks in joints of cliffs. It then freezes. We know that it expands by nearly 10%, and then that then stresses the rock in the crack, causing bits of it to break, and then you get the cracks then develop further, bits are broken off, and then when we get the ice melting, the thaw phase, it then kind of penetrates further into the rock, and the process then is continuous, a continuous cycle. And the key thing here is that all of these, what they do is they weaken the rock. They make it more vulnerable, and therefore mass movement, that downward movement of material can then kick in. So pressure release, I've done this on the bigger slide here. So if we look at the gist of this here, the rock that might be lying on the top is exposed to maybe different temperatures, whatever reason that might be, maybe erosion as well. And that takes, as that gets broken off, the rock underneath is has less pressure exposed to it, so therefore it can expand um, and then break off. So that pressure release, so think you put your hand down on something, you take it off, it has the ability to bounce up and weaken. Thermal expansion is where the outer layers of a rock heat up and cool down differently to the rock within, and therefore you get this sort of separation of rock from that. So that can be like granular, it can be like layers, um, like onion skin, whether we sometimes calls it, um, exfoliation type sort of thing. Salt crystallization, this was a good one I think this one particularly is a good one, along with freeze thaw, would be one that on the mechanical, the physical type of weathering here. This is where when salt water gets into cracks or the pore spaces within the rock, as the water maybe evaporates away, the salt precipitates out, forming crystals. These stress the pore spaces or the cracks. Um, as the salt crystals build up, they occupy a larger space than the pore space does, and it stresses the rock, and then it causes the rock to break. I think that's all four I've been through, and you can see the diagrams. You'll see these on the next slide. So there we got our freeze thaw, our thermal expansion, our pressure release, thermal pressure release, and there's our salt crystallization. So the next set, chemical weathering. Remember, both physical and chemical weathering can take place at the same time. Here, what we've got here is this is carbonation. This is where the rock dissolves. So this is where acids in the water react with the rock and cause it to chemically change, becoming weaker. So there are several. I think the one that we talk about the most, is probably the easiest one here, is carbonation. Rainwater combines with carbon dioxide, forms a weak carbonic acid. This will react with rocks such as limestone and reacts with the rock, and then you get this solution that's created, which is calcium bicarbonate, and then that can flow away with, whether it just flows off the top of the rock or infiltrates down. And that's very slow. Okay, but there are other ones that you could also mention here. So you don't want to get too bogged down in all of these, but I think it's worth learning some of them. All of these result in the transition of rock into something else that's weaker. So let's have a look at oxidation here. So we're saying here, when exposed, the minerals within certain types of rocks, they react with oxygen. The iron, if we use that as an example, there's a particular one there, and it reacts in these sort of acidic conditions. And then we get something called rust, which is quite weak. And you've seen this, you can see this on metal. Cars used to see a lot of it before. I think the paintwork's obviously got a lot better, but underneath it all, that can still happen. So it weakens the rock, but you would say this would take place where the rock itself is iron rich. Okay, so or at least between the structures, there's a lot of iron-rich cements. You don't need to get too bogged down in any of the chemistry on this one. It's just having an awareness, really, something that you can write a simple definition. If we go to hydrolysis, this is again where you get a reaction taking place. Acids in the water with certain types of rock combine, and they produce secondary minerals such as clay, and you get then some sort of like solution running off. Granite, which is one of the toughest rocks out there, reacts with the hydrogen in the water and it produces a number of substances, and then some of this it flows away with the water, and it leaves a slightly, it leaves a weaker aspect to the rock structure. Okay, hydration, and the essence of this is, and you can read this through more in depth, this is where when water gets added to the rock, the water becomes incorporated into the rock, but the rock has changed. The key thing here is it's got larger, it expands, so obviously becomes heavier with that in there. It obviously changes its nature, it's no longer the same type of rock. So they've talked about an example here, anhydrite, taking in water to form gypsum. Because of that hydration, the surface of that rock then starts to flake off, break off. Okay. I think the last one I'll go through here is solution. So other minerals such as iron are only soluble in very acidic water. So there you go. It had to be a very acidic conditions for that to take place. The minerals dissolve in the water and then they would be sort of carried off again. I think the key thing here to remember is that there are several ways rock can break down on the spot in situ chemically. Here are some of them. Learn some of them. Your teachers will tell you exactly which ones they want to do, but to have a range, I think, is important. Then on the next slide, you'll see these 5 illustrated with a few notes. So that one there, maybe I should have put a different one in because the rest of these have actually got some information on them. There's the 5 there. This one here would be carbonation. You can see it losing its features and things like that. So again, remember the contribution of this is that it makes the coastline more vulnerable either to mass movement or further attack by marine processes such as erosion. So the final set of things I'll look at here is biological weathering. So what we have here is vegetation in this instance, in these 2 photographs here. Here we've got the tree growing. This instance, the physical size of the root grows into the crack, and as the tree gets bigger, the roots grow longer, bigger, and they grow in the crack and they stress the rock. So although I would say this is biological, obviously, but I would say that works in a mechanical action. Okay, over here we have this, it's called lichen, and basically these secrete enzymes which break down the rock so they can feed on it. So you see this on certain types of rock. All of this is lichen. You see the different colors. Looks like a bit of dried chewing gum, maybe. This looks a bit like moss, um, or scabs, whatever you want to call it. But make sure you learn. You don't need to learn them in depth and things like that. Other things, and I'll just move on to the slide for this. So this one here said about the tree roots, and I've also gone on to things like plants doing their work as well. But also remember things like animals, everything from insects, they can burrow physically, rodents, they can also burrow as well. Everything excretes, they often have like acids in there that can break down rock. And some things, as I said, like, they can secrete enzymes as well to help them break up the rock to feed on. Okay, so it's really a combination. I mean, ultimately, biological weathering incorporates chemical and mechanical. So finally coming to the end part here on weathering as a process. So it definitely plays a role at the coastline. It definitely plays a role in the development of the coastal landscape. Well, the key thing I would say here, it makes the coastal landscape more vulnerable to other processes. And in some situations, for example, if you have a 300 meter tall cliff and you've got rock falls or slides and it's got nothing to do with the sea directly, and you're thinking, why is that happening? And you might look at the climate, you might look at other things and think, well, it's heavily weathered, that contributes to mass movement, and parts of that cliff slide off or slump into the sea. And you're thinking, therefore, weathering is a dominant process here rather than erosion. Then if you took something like the overhang of an arch on the coastal landscape, as the arch becomes developed, you would say weathering plays a significant role in the rock, weakening, breaking off, and leading to mass movement. And you would say probably both weathering and erosion play a key role there, both leading to mass movement. So that again, that's one of the things that you have to consider. So back over this. This is part 2, the first section of the sub-area process that I'm doing. Okay, so the whole lesson of this was to go through what weathering is on its own, the 3 types, physical, chemical, biological. Gone through some of those quite briefly. That was deliberately brief because I don't want you to write down too much detail. Remember, this is a coastal topic, so it plays a role. We don't need to get too bogged down in it. Okay, thanks for listening. I'll see you for part 3, which will be on mass movement.